Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we'll see an application of the new f-test formula that we have discovered for model comparison. So let's start by looking at the models. We're going to have a sample of 100 observations, which is going to apply to both regressions, the simple and the more complex one. We have the restricted model, the simple model, which is just y equals to beta null plus beta 1 x1 and epsilon. And the residual sum of squares, let's assume, after running the regression, we see that it's 500. Then we have an unrestricted model, which looks like the simple model up until here. And then we have two additional variables that are being added to add complexity. The residual sum of square collected after this regression is 420. Now, from here, we can see and gather the other information that we need for the F formula. So it's very clear to see that the number of variables in the unrestricted regression, so the K unrestricted in here, is 3. But what is the Q? Well, if we look and compare the restricted model to the unrestricted model, it's very clear that these two are the variables that we are jointly trying to see if they matter. So our null hypothesis in this case would have been that beta 2 is equal to 0 and beta 3 is equal to 0. Alternative hypothesis is at least 1 is different from 0. But what that means is that the Q is simply 2. Now that we have all the information that we need, let's jump right into the formula. So step 1, compute the F statistic. The formula, as a reminder, again, is RSS for the restricted model minus RSS of the unrestricted model divided by Q. Then all of this RSS of the unrestricted model divided by N minus K minus 1. Keep in mind, this F statistic under the null hypothesis, meaning assuming that all the assumptions are holding, because we should never forget about the assumptions, should have an F distribution with degrees of freedom Q and N minus K minus 1. Let's compute this properly. So now that we have all the information, this is simply 500 minus 420 divided by 2. Then all of this divided by 420 over 96. If you do the computations, you'll find 40 as your nominator and a number 4.375 for your denominator, which approximately will give you 9.14. So that means that your F star, the one that you just computed, is 9.14. Now, before we make the decision, let's do step 2. Is find your critical value. And let's say we use the 5% level. From the previous videos, you'll remember we have the F critical for, normally we would need 2 and 96 as your degrees of freedom. 96 is a number that you won't really be able to find. So the most, the closest to it would be F2 with 100. And we already know this is approximately 3.09. So step 3 is decision time. Since our F star, the one that we computed, is actually bigger than our F critical, and I'm gonna add here the degrees of freedom as well, then we reject the null hypothesis. So this F statistic is quite large. What rejecting the null hypothesis means, so interpretation, adding x2 and x3 improves the model enough to justify extra complexity. Keep in mind, it does not mean that both are individually significant, and it does not mean the model is causal. So these takeaways still remain in place even when we use the F statistic to do a model comparison. This model comparison F-test tells us whether a larger model genuinely outperforms a nested, simpler one. With this video, the full saga of the F-test formulas and when to use them for now should be finished. Keep in mind, we will have to use F statistics for different types of tests in the future. But for now, these are the most basic ones before we jump into all the other elements of regressions. So stay tuned, and I'll see you in the next video.